Good to see you. Let's see. We have a brown bag today, right? So you guys, what's the title? They quit giving us announcements up here, but I think it's useful to.
It's Alex Colvin, who's a recent PhD. I think she graduated from Auburn, and it's on the Creek Indians.
Okay,
or something like that.
That sounds interesting. Over at the Boykin Center, which is, if you go right across the railroad on Donahue and then left and then first or second to the right. Second on Boykin Street. Okay, gang, what's the map about?
Steam algae.
All right, what kind of clues? One?
Well, the lines all go through water. Well, a lot of them do.
Yeah.
Rivers.
But look where they all end up. On rivers, but not just any rivers. If I put a map of the Mason-Dixon line, would that give you any clues? This is the Underground Railroad. So when the people made it to the border, those were the routes they took further north. And here you can see representation of how many people left different areas and so on. So I thought that was an interesting map. I had never seen it before. And we're going to run out of time in this term before I exhaust all of my interesting maps. So, so I don't know, maybe I have your email address. Maybe I'll just send you some links or something. All right. Unfortunately, for me, maybe not for you, but unfortunately, I'm not going to be here next week. We're going to have to be in Birmingham on Tuesday, Wednesday. But you don't get a day off because I have guest lecturers coming in. So Mike and Sue, they spent careers in the military working with maps and GIS and remote sensing and all kinds of things. So they will talk about global positioning systems, GPS. Now, I may mention that a little bit today, but I'll let them get into it. And then multispectral imagery. And Mike was talking to me this morning, hyperspectral, which is something that's come along since I was involved. So anyway, I hope you find it interesting. I'm sorry that I'll miss it. Okay, let's see. We were looking at, and what we're going to get into more and more for the last 2 days that I'll be with you is all of the computer technology stuff. So what are some of the developments, some of the things that have come along? Well, computers, big ones, little ones, satellites, various kinds of new thematic mapping techniques. We can automate a lot of the things that we used to have to do by hand, which was very time-consuming and difficult. And so the technology allows us to do new and different kinds of things. Of course, the internet has been a big development. And mobility, these things travel around in our pocket. And a big one is GIS, Geographic Information Systems. I know I have referred to this, I've alluded to it over and over during this course, and last day of class I'll finally get around to talking to you about it if you're not fully aware of what that is. And all of this stuff ties together. You know, you can't talk about one without the other. You can't talk about remote sensing without talking about computers and processing of the different spectral bands, the things that we get back. So all of it links in, ties together. So we'll be looking at some of this in various ways. Got into this a little bit last time. That's looking at essentially what has to do more with surveying, but the Earth is made up of an ellipse, or it is an ellipse. You have the geoid that we use for calculating coordinate systems. We now observe the Earth from platforms, various satellites, but also aircrafts and drones and all kinds of things flying above the surface. And we collect data from the Earth reflected in various parts of the electromagnetic spectrum. So we can analyze all of that. Talked about some of this last time, how we might go about classifying, looking at various signatures of different kinds of land surfaces and relating that to the spectral bands that we're collecting from the satellites. And so where you get these intersections between the known signature and the image that we're getting back, then that allows us to do some classification of the surface and come up with maps that look like this. Whereas before you might have to do a lot of hand drawing and analysis. Now it's all automated. Talked a little bit about LiDAR, laser imaging, detection and ranging, which is very topical these days. We can tell what's going on under tree canopies, on the surface of the Earth, and to some extent penetrate into ice and sand and other kinds of things. Use this in conjunction with radar imaging, which does some similar kinds of things. And you have images that look like this that allow us to detect things like ancient archaeological sites, and this has been very extensively used in various parts of Latin America and Africa too, for that matter. Okay, talk a little bit about computers. And we have all lived through the computer revolution, or most of us. Looking around the room, I don't see anybody under 30 years old. And of course, at one time, this is what they looked like. Big UNIVAC systems. I started working with an IBM 360, which occupied a room at least as big as the one we're in right now. And this is actually one of the first maps. Well, not really. It was a map like this. This was done a little bit later. A laboratory up at Harvard, Laboratory for Computer Graphics, developed a technique where you could make a map with data input. You would identify the outline and then the central location of various countries in Africa and put data into the program, and it would produce a map like this. It was called SYMAP, S-Y-M-A-P. And we were so excited to be able to do that and turn out all kinds of maps. And this is how it made the map. If you look carefully, this is printed off on that old green paper that we used to use. And what it would do periodically is stop the print head or stop the paper from moving forward. And the print head would strike the same place over and over again and create areas of blackness, superpose various kinds of symbols and characters, and so it would create dark and light areas across the map. And it was quite innovative for the time. And so you could create then these choropleth maps or isopleth maps that would show distribution. So that was one of the first efforts at automating map techniques, and made a lot of these things, and it was pretty cumbersome to use. You had to input data, carry your cards all the way over to the computer center, punch the cards. Anyway, well, this is how we do it today. Much simpler, much more straightforward. Of course, computers, we do a lot of things in spatial analysis with computers. Everything has been made easier and faster. A lot of normative analog models model hurricanes, for example, and geometric kinds of patterns. This would be central place theory kind of thing that Kristaller developed. In geography, we use a lot of network analysis, geometric analysis of various sorts. All of this then lends itself to computerization. Routing algorithms. So every time you pull your phone out and ask for directions from here to there, it's implementing some sort of routing algorithm, knows where the roads are, and so you can calculate the shortest distance, the quickest time to get from one place to another. Or you can do things like this. This is a typical traveling salesman problem, which is an algorithm that if you were to start in any state capital in the United States and say, okay, I want to visit every capital in the country, tell me the quickest or the shortest distance to travel. And so it would have to calculate, using a variety of inputs, parameters. And essentially, this is the one that you would come up with. And so it's interesting. And this has many other applications. Well, the name of the problem tells you that if you're a FedEx delivery truck and you need to go to so many different points, then what is the best or the quickest route to get there and get back to the place where you started? Various kinds of statistical analysis, not going to go into a lot of this stuff, but these are all things, of course, that are done in spatial analysis today. One thing to point out, a lot of times in geography or doing analytical work, you are using spatial units. In this case, I've just used a county map of Alabama. You're using spatial units as samples or as a population of data. So maybe you want to do some sort of analysis of the population, some population component in Alabama. And so you will use all of the various counties as your total population, or maybe you'll draw a sample from this group. But it's not as simple as doing other kinds of data sampling or statistical analysis, because one of the requirements for doing statistics is independence among the units that you're making use of the individuals. Well, if you're talking about geography, then there's something they call spatial autocorrelation. So you can pretend like Lee County is an independent observation from, let's say, Tallapoosa County, right next door, but that's probably not correct. There is probably correlation among those units. And so to deal with that, geographers or people who are involved in spatial analysis have developed a whole area that has to do with spatial autocorrelation. We have to be careful of those kinds of violations in typical statistical theory. So anyway, we get into a lot of that. All right, internet is also something that has exploded on the scene, and we use it every day, all the time. Here you see some of the major trunk routes across the country. I got a kick. I sat down and thought, well, what are the browsers that I've used in my lifetime? And I don't know if you recognize, that's the first one. What was that one? That was the first. I still remember going to somebody's office and say, wow, look here, look what you can do now. And that's Mosaic. That was the first web browser that was available. And then we had, I don't know, Netscape and Firefox and Safari and all of these other ones. And I think the most used now is Chrome. So on the internet now we can do a lot of things, and I'll come back and mention that. One thing that we do is interactive thematic mapping, mapping data of various sorts. There are various websites where you can input your own data, or you can use data that's already been collected, and you can create maps. So here's one of them. This has to do with oil spills, and you can plot and simulate oil spill areas, or you can look at the areas where oil spills have occurred, and it includes a lot of different features. So, and I'll put the link down at the bottom of each one of these slides. So if you're truly interested, you can go back and look at the actual site. Here's one that's useful to map census data, and it's simply datamapper.geocensus.gov. And so you can call up any one of the statistical tables from the U.S. Census over here on the left and create categories. I think it just does choropleth maps. I don't think it does any other kind of mapping. tell how you want to break the categories down. So here we're looking at quantiles. And it will then display a map. So here we're looking at average family size. So the darker the color, the bigger the average size of the family within each one of those counties. Here's another one. This is mapping population by income at various cities. So Atlanta, you can see the red would be wealthy areas, the darker, the bluer color would be poorer regions. And one thing that stands out as you map urban areas, of course, is that generally there's a negative relationship, or let's see, there's a positive relationship between income and distance to the center of the city. Further out you are, generally the higher the income. So that one was in radicalcartography.net. Here's another one. This is urbanobservatory.org. You pick cities of the world and you can compare cities. And so I think you can put up 3 at a time. And so I had Rotterdam, Rio de Janeiro, and Atlanta. And it will give you imagery. You see I have that checked over here on the side. But it will also let you map all sorts of data. So here I've decided to pick population density. And so you can see the relative density of the various cities using, sort of side by side, using the same values to compare one city with another. And it's interesting to see how in certain areas, well, let's just look at this. This is Latin America, and here is Atlanta. And you see a much more dispersed pattern in, let's say, cities of North America than you would in Latin America. So population, the yellow values would be very high density areas. And notice no yellow values over there in Atlanta, comparable to some of the more dense areas in Rio. So anyway, it's an interesting comparison. It's called urbanobservatory.org. Here's another one that deals with net migration. All of this freely available on the internet, by the way. And here again, you select various data inputs. Now this has mostly to do with population and movement. So let's see, I don't think I put a date on that one. Let me look at this. Okay, here's total net migration in the 1950s. Early 1950s. And so blue is areas where people are moving in, and red, or orange, I guess, are areas where people are moving out. So the population density is decreasing throughout most of the country, all of these areas, and increasing in a few areas. Of course, South Florida, Southern California, and now compare that to 2000s, and you see a much more scattered area. The middle of the country, the High Plains, is still an area of depopulation. Farms are getting bigger, people are moving away, not staying on the farms. But more of a mixed pattern here and there. Still, if you're looking at Alabama, out-migration in southwest Alabama, but in-migration around Birmingham, Mobile, much of Tennessee, people moving into Tennessee. Interesting, moving out of Kansas, but moving into, or more so at least, into Oklahoma. A lot of people coming into Wyoming. So, and all of this, and you can, it's from this site right here, net migration up at the University of Wisconsin. All right, there's some interactive maps that are just put out here and there by various other entities. This is done by the Washington Post. And it shows pain pills dispensed, let's see. There's a date on here, and I guess I didn't listen, but yeah, 2019. And I'll zoomed into the Auburn area. So these are individual pharmacies, and you're seeing how many pain pills they are dispensing. And as they get larger, okay, this is per capita, per person. The circle size is the total amount, but the coloring tells you what the per capita, how many per, looking at the local population of that area. And so identified 5 Point, that's across from the hospital, which makes some sense. But I was surprised that the largest one here in Auburn was, what was that one? That's Dean Road. Well, anyway, I should have. You can go with your mouse and you can. Oh, here it is. Yeah, the drugstore, 464 North Dean Road, and it's interactive, so you can click on it on any one of these, zoom in, zoom out, and compare different areas. And of course, this is all topical with the opioid epidemic that we have experienced. Went over to Dadeville, and there are a couple over there that are pretty significant. So pretty good number of pills being dispensed, pain pills, per population out here in this area. Okay, another source, another place where you can create maps is what they call fusion tables, and this is an application that Google has now. I think they have. I mean, it's still available, but they are moving on to something else, so I'm not sure fusion tables are being supported to the extent that they were before, but you can still make maps. I saw this sort of a diagram showing where Alabama students go to school, and I thought, well, that just doesn't seem right. I mean, it's got most of southern Alabama going to Troy, and a few here in Auburn. So I said, well, let me see if I can think of a way to do this a little better. So students at Auburn, you can go to the Auburn Bulletin, the catalog, and in the back they will have the number of students from each county in Alabama, plus from other countries and so on. They break it down by gender and so on. So I was looking at this column over here, total. And so I got to think, okay, for each county, and this is just the size of the circle doesn't mean anything, but just to sort of illustrate what I was trying to get at here. If you think of the population of a county in Alabama like Autauga, a certain percentage of them, a certain number of those people will end up at Auburn. Now, you could stratify by, that age group where kids are going to college and all of that, but just look at the total population. A certain percentage of them will go to Auburn University. And so I've created a little Excel spreadsheet. So here are the total number of students from each one of those counties. Here's the population of those counties at that time for when I collected the data. And so the right column is really a percentage value of what percentage of the total people in Autauga County could be thought of as being students at Auburn. So it's all pretty simple kind of thing with some little formulas, and you just calculate these values all the way up and down. So the next step then is to map all this stuff, see what it looks like. And this is where Fusion Table kicks in. You can do all of this automatically on the internet. Just upload your data and put the data in, set the categories, and make your maps. You can define the colors, how much goes in each one of these categories. And so the first thing I decided to make a map of is the home population. And so this is basically population of Alabama, just by counties, of course. So dark blue, these are heavily populated. And this, by the way, is not by density. This is just the total population within each one of these counties. And then the deep red are the counties with few people, and you can see the various shading in between. White would be sort of halfway. Okay, next thing is to show the student population. So where are the students coming from? Well, again, the dark blue would show where a lot of Auburn students come from. Of course, obviously a lot from Lee County, but also a lot from Mobile, from Jefferson County, Birmingham. So that's the total students. Put these two side by side. So there's total population. Here's total students to Auburn. And the maps, as you would expect, look similar because if Birmingham has a lot of people, then you would expect a large number of students to show up at Auburn. But the next map is the more interesting one, is what's the percentage breakdown? What percentage, what's the variation in the percentage of the county population that shows up at Auburn? And so here's the map for that. And so you can see over here in East Alabama, you have pretty high percentage, and these of course they don't seem like big numbers, but they're relative values. And then fewer, of course, over in East Alabama. So you get a very interesting and really predictable spatial breakdown of this pattern of where students are coming from, Auburn students are coming from, what part of Alabama. And so then you could sit back and analyze something like that. Well, why is that? I just did this to let you see which counties are which. And how would you explain it? Well, one obvious is your kids are going to the nearest big university. Over here, they're going to Tuscaloosa, University of Alabama, and over here to Auburn. And we're also drawing from southeast Alabama. But there are other things that play into this. We have a strong program in agriculture. So you could say, well, the wiregrass, that's an agricultural area, and so we would draw from that area to be expected. You can, might be showing a tendency, different tendency going to college. Maybe people over here in West Alabama don't go to college as much. Not to say that we're smarter over here, but it would be a possible explanation. So there's more than just the competition between the universities. That sort of situation is referred to as an intervening opportunity. If you live in West Alabama, then Tuscaloosa is an intervening opportunity between Auburn and your location. Yes?
Another thing that I would think would impact that is the relative cost. If there are nearby community colleges, particularly ones that have
Absolutely.
4-year,
Mm-hmm.
then
Yeah.
people don't want to finish college with debt if they can avoid it.
Yeah. And so that whole business of intervening opportunity applies to other schools as well, junior colleges, out of state. And you can pick out maybe the effect. Okay, so here we have Troy down here, perhaps drawing some students from those areas. So it's kind of fun to sit around and puzzle over these sort of patterns. Yeah, Gabi. West Alabama.
Is that considered an affiliate or a satellite of UA?
Well, yeah, I don't know. Is that true? It's not.
Same as Troy and Jacksonville and North Alabama.
So they have nothing to do with
Right.
Those used to be called teachers' colleges,
the normal.
and then they became universities.
Now this map, keep in mind that it's not reflecting enrollment at any other school. It's just showing Auburn University enrollment. So that's, you can speculate about other schools drawing from here and there, but really all we're looking at is how many students from each one of these, how many people from each one of these counties will tend to come to Auburn. So, okay, well it's not a very deep analysis obviously, but I just wanted to illustrate that here again you can go up to fusion tables on in the Google environment, and you can do these sorts of analyses. Here's another one. This is ArcGIS Online. Arc is produced by ESRI. I forget what the Environmental what that stands for, but it's the biggest GIS company, and they have an online presence, and you can upload input data of various sorts and do similar kinds of analyses. Now, you do have to create an account, but that's simply a matter of giving them your email address and creating a password that's completely free. And then you go to make a map and put your data in. So I'll show you one. Okay, so I downloaded some data from the census. And I got this from FactFinder, census.gov. It's got the 2010 census, and then they have estimates. Here again, you have the county of Alabama. It has estimates for various years. So they don't actually go out and take a census, but they do estimate for subsequent years based on a variety of inputs. So download the data, and okay, so that comes from the census. This also comes from the census. These are estimates, so not recorded by interview. And so go up and in the ArcGIS, again online, you create your own map. Say, I'm going to add data, layer from file. It's all very easy, very simple, very transparent. And what I was interested in is, and I did this before I uploaded the data, I had a % change. So I'm interested in difference between the 2010 census and the estimate in 2018. So how much of a change was there? So I calculated those changes. Now this is, and you can see increases and decreases in some areas. And so then I decided to make a map of this sort. So the circle size here tells you what the total population was in 2010. And then the color of the circle will tell you the % change. So the darker the color, the more percentage change within that county. And you can see where the growth has occurred. Auburn is one, Lee County, Baldwin County, southeast of Birmingham, Huntsville. These are all areas that have boomed, and you can see the faded out colors here in West Alabama, no growth or decreased population. So again, anyway, this is all free available online. Just go up to this site. Yeah. No, that's not it. This one right here. esri.com, and then go to eventually out to ArcGIS online. So there's a lot of things you can do online, and again, I'm just showing you the free stuff. If you want to pay, you can do a whole lot more. But I'm retired, so I can't afford stuff anymore. Okay, you can also download free software to your personal computer and install it on your personal computer. So you can do that. Google Data Studio, here's another one. Carto, you can set up a free account. This one may be online too. I'll have to go back and look at it. I haven't actually used it. But free for educators and students. And so if you still have your Auburn University ID, or all you need is an email that has an EDU in it, and you can sign up for free or pay a fee. It's a very, very low fee to use this one. Tableau is available. Now this is a commercial product that they will sell you an advanced version of, but you can also download and install what they call Tableau Public, which is a sort of a reduced version, and simply go to publictableau.com, and it's pretty powerful. It does quite a bit of analyses, map analyses. Various other kinds of PC-based systems, again, many of them commercial. I'll just show you a couple. There are actually hundreds of options. And a lot of times the mapping part of it is sort of hidden in among the various controls and options to do graphing and charting. So, you know, and I think Excel is that way. You look in the charting and graphing area, and you're going to find what you need to do in mapping. So it may not be actually listed as mapping. A lot of times these things are referred to as business geographic programs. And there are many, many, many versions of this. You have some that sort of do mapping on the side. I think Excel would be an example of that. And then you have others that are actually dedicated to mapping. So a program like Maptitude, for example, would be just purely dedicated to making maps of all kinds and all sorts. And so let's say if you're a journalist working at a newspaper and newspapers have to produce maps, then you would probably want to have the company invest in one of these programs that will do mapping for you. So here's Excel, and they call it Power Map, and you can do things like this. And so if you have Excel, then now this would be the more recent versions of Excel. If you're still working with 2003 version, it's not going to do all of this. But it will identify the counties and states and things like that. So you can make some sort of standardized maps. Now, if you want to make a map of, you know, the distribution of some sort of odd territories, like if I wanted to map provinces in central Ghana, I'm not sure Excel has the built-in capability to do that. But it might. I won't say it doesn't. And again, this is all similar. Again, choroplaths can set the shading, the coloring, the values, all of the different range intervals using these sort of things. I mentioned heat maps before. This is easy to do, very common using Excel. And Google Earth will also do this. Now I'm going to save Google Earth to talk about the last day of class, and I'm sort of kind of squeezing some things together, so I'm skipping over a few things as we go forward because I won't be here next week. Okay, a few comments about data. A lot of things to consider. First of all, what is it that you want to map? What's the item of interest? Where is it coming from? What type of data is it? Is it number data, or is it imagery? Is it qualitative data of some sort? And that, remember from earlier discussions, that will determine how you go about making map, how you color the map, how you draw it in, how you illustrate it. So if you have nominal data, if you have data where you simply have things that are qualitatively different from each other, then you probably don't want to use changes in shading, dark to light. You want to have patterns that look different from each other, that are easily recognizable, or maybe colors that are different. So you wouldn't use the same hue with different shades, dark to light, but you would use, you know, red and blue and green and things that are different. So the kind of data will determine, or it will influence the method by which you go ahead and illustrate this on a map. You want to make sure you avoid confounding variables. Talked about that. If you're not careful, depending on the mapping technique you're using, you can end up mixing up things like, well, population and the size of the area that it's being drawn from, and any number of other kinds of things. So you have to put some thought into making sure you isolate the variable, and you exclude or you control for other things that might creep into understanding what the map is about. Obviously, quality and reliability of the data. Many of the data that you use, especially in mapping now, will come with metadata attached. And metadata information tells you about the data. You know, where does it come from? Where was it collected? What's the reliability? You know, all kinds of information about the data that you're using. So pay attention to metadata if you have access to that. Obviously, recency, collection, when was it collected? How was it collected? Is it a sampling technique? What is the sampling methodology? Is it good sampling or not? You know, are you just collecting information from people you know? Or making phone calls to landlines and excluding cell phones. There are all sorts of things to keep that in mind. Yes, Marilyn.
Example of that is our census that's been taken the last few times. The census data is population, household information based on population, like when I was 6, there's the income and education, because of the component is 139, so it's not the same sample set, it doesn't give you correctly.
That's right. That's a really good point. And so you have to be careful as you use census data. Maybe you've had the experience of being interviewed in census, and you get the long form with a whole bunch of questions and all, or you get the simpler form. So yeah, be aware of that. And I'm assuming that the Census Bureau is pretty careful about the way they sample, that they stratify and control for, different population groups and income and all that sort of thing. But you're right. Let's see. Also, be aware, and again, this relates a little more to what we'll talk about later, that when you're dealing with maps, then you are associating attribute information, the data, the numbers, with geographical areas. And so, what is the nature of that? What is the nature of that association? Does the data correspond to areas, or does it refer to lines? Transportation Department, for example, maintains many maps and a lot of data, but a lot of the things that they tag are points and lines, not areas, because they're interested in roads, they're interested in intersections, variety of things like, or you take a gas company. Well, they might keep track in their database of metered units, household addresses, or pipelines. Most of those are linear or point information, as opposed to area distributions like I'm showing on the map right here. So that's something to keep in mind. What kind of data? What's the relationship? Spectral readings. Anyway, you can read all that. The size of the data collection unit, of course, is important. You can make a map of states showing the same data, or here's county-based, or of course you could go down to numeration areas, census blocks, or you could map countries, large units. So that's going to make a difference. Remember that the expense increases with the number of collections you have to make. So if you're collecting for counties or smaller units within counties, then that's going to be more expensive, more difficult than collecting for larger units. So the geographic detail, remoteness, if you're trying to gather data from the central Congo, then that's going to be more problematic, more expensive than from somewhere else. Frequency of collection, uniqueness. How hard is it to get? I just listed things that I could think of as I was sitting there. Okay. All right, let's take a break. We'll come back and move on to something else here and come to think of it. But okay, so anyway, there are a lot of things to talk about related to data, and we just mentioned a few here today, but not really even scratching the surface. Comes down to it. There are a lot of ways of automating data collection now. And one of them is crowdsourcing, which I'm sure you're familiar with. I don't know if you know this or not, but you probably wonder, well, how does Google or Apple, how do they know where the traffic is blocked? So if you look at your phone, you get the red line, say, well, I don't want to go that way, go somewhere else. Or Waze or any of the other ones. Well, it's all crowdsourcing. And what that means is that Google, just to use Google as an example, if you are interacting with your, now you do have the option of turning off location sharing on your phones. And so, you can remain private, not let anybody know where you are. but not, most, if not the great majority of us don't bother to do that. So Google and the cell towers, they all know where we are. So they can tell if we're moving down the highway, and they can actually calculate what the rate of speed is. And so when everybody's rate of speed slows down, then they can make maps here that they can color the map differently depending on how fast the traffic is moving. And so that's called crowdsourcing. And that's how all of that works. And you may have seen the headline in the newspaper a few days ago. A guy got 99 cell phones, put them in a wagon, and walked across the bridge, and Google Maps showed traffic blocked.
Moving very slowly.
Moving very slowly. I got a kick out of that. Well, first of all, who could afford to buy 99 smartphones? I mean, I don't know. He must. What's that, Robbie? Anyway, so I got a kick out of that. That was kind of neat. Yeah.
Was he intentionally trying to screw with Google?
He was, yeah. And it was, I don't know, it was some kind of, might have been an art thing or something, just to prove the point that, but it seemed like a lot of effort to go to make a point. Okay, there are many sources of data, obviously. Private sources.
According to Topper, there are two sources of data in statistics. Statistical sources refer to data that are collected for some official purposes and include censuses and officially conducted surveys. Non-statistical sources refer...
Sorry about that.
That's an eavesdropping surface.
So, I lost my microphone now. It's completely confounded here. I was really, okay, you hear me all right? Okay. Talk about things happening unexpectedly. I was at a meeting, we were in central Mexico somewhere, where was it? A conference, professional conference, a room about this size. And the fellow was giving a talk, and he was using, the old-fashioned slide projector with the carousel and everything. Well, there was an electric storm outside, and all of a sudden the lights went out, and it blew out the bulb in his projector. Well, the lights came back on, and he reached in his bag, pulled out another bulb, screwed it in. Another blast of electricity and went out, blew out his bulb. He did that 7 times. Changed his bulb in his projector. Now, bulbs are not cheap, so that was something else. But I was just absolutely amazed. And I asked, I said, I've never seen anybody so prepared as you are to have 7 different bulbs. Anyway, so you never know when things are going to go wrong. Okay, well, anyway, back to data sources. Private collection for a fee. Now, this has become quite common. I put a drone up there, but it's more likely to be an aircraft. So you hire somebody to fly over an area. Let's say you're doing a real estate development or some new site for a factory, and so you just simply hire somebody to fly it, and then you have the data and you can analyze it. And by the way, collecting spatial data from an aircraft or even from a drone, which is done now, is not quite as simple as you might think. It's not just pointing a camera to the ground and taking pictures. Because if you're going to use it in serious mapping, then you have to correct for all kinds of things. For example, if the plane is not perfectly steady, if it's got a wobble. So that has to be compensated. Usually there are gyroscopes that help control all of that. Also, the camera is collecting information over a broader area, so the size of the features directly beneath the aircraft will be different from the ones off to the margins, off to the side, so you have to compensate for that. So, it's not, again, if you're doing serious collection, it's not just a matter of going up there with your camera and taking pictures of the ground. So there's a lot of data that's private and you could purchase for a fee. There's also private data that is free within limitations. So here's an example of Google, Google Earth, or Google Maps. That's all available. We can all use it. We can all access it. But if you want to use it commercially, then that's a different story. You would have to pay a fee to make use of that, to do it legally. There are government sources, some of it obviously restricted, but others, a lot of government data available more or less free, again with some limited restrictions. So maps, our university here is a repository for the Army Map Service maps. Now we don't do as much with paper maps anymore, but that's the kind of thing that's available.
Would other places have that kind of access to the information?
Other places.
I'm thinking about China and Russia.
They would have access to anything that's available on the internet or of that sort. I'm not sure. I guess there would be some limitations at some level on some kinds of things. So I'm trying to think of examples here. For example, in Alabama, we belonged to a consortium that had special access to certain kinds of data related to preparedness and emergency, where all the fire departments were and things like that. And we didn't have to go through a full clearance, but we had to specify who we were and what our interest was and what. And so that could be checked out, and I'm sure if a colonel from the Chinese Army wanted to get into it, probably not as easy. Yeah, Dwight.
About 10 years ago, it was a Tuesday, I was teaching English in South China, and using Google Earth.
Yeah.
On Wednesday, the icon had vanished from my desktop. There was no trace of the program on my laptop at all.
No kidding. That is really interesting.
It's just gone.
Yeah.
No explanation from Google, obviously none from the Chinese government.
Now, I know that's been a point of contention with Google because they do have limitations and restrictions, not only in the mapping, but also in the searching and all the other stuff that,
That's what I was wondering.
yeah. Interesting. So, oh, let's see. Something else popped into my head, but I don't remember what it was. Okay, so open with some restrictions. Now, of course, the government, we have a lot of publicly available data. Universities, local state offices. So, for example, all the USGS topographic maps, they call them digital line graphs now, for, I would guess, every state in the country are available online on the internet. You can download this stuff. So, Soil Services, USGS, Weather Service, all of these things are more or less freely available. Aeronautical charts, you can get any of this kind of stuff. And this is all maintained by the government, but made available to the citizens for whatever you want to do. Satellite Earth imagery, Landsat, launched in '72. First, now there are a whole series of Landsat satellites. And then the data were made available for public consumption. So you could download it, you could, at first it was not as easy to get, and you might find paper copies. But, and then a lot of subsequent data also available. Another thing that's been made available that's been very useful are the Tiger files. And Tiger stands for what? Topological Integrated Geographic Encoded and Referencing. For many years, the U.S. government embarked on this project to develop Tiger files. And what they did was basically digitize. And digitize means that you're transferring information into a computer. So you're moving a pen or some sort of device along a map and clicking at different nodes or intervals, and so you're taking real world data or data off of an image, a satellite image, or an existing paper map, and you're turning it into information that a computer can use, digital information. And so that took a good bit of effort early on because a lot of this was done by hand. So they digitized all the roads, the political boundaries among not only states and counties, but also enumeration areas, all the census divisions, all of this then had to be put into the computer. And it was finally finalized, completely released in the early 2000s. So the Tiger files are now available to anybody, available to use. So they've been incorporated into most publicly available mapping data. GPS data is also available. That's how we can all use our cell phones, that we all have access to those satellites that are flying above the ground and transmitting GPS information and triangulating, and then we can tell where we are. At one time, I think into the 90s, this data was partially encrypted, or it was not as precise or as accurate as a result of efforts of the federal government. They wanted it to be precise and accurate for military purposes, but they didn't want, for example, the Chinese to have access to the same level of location ability as we did in the United States. So I think it was under Bill Clinton where he said, no, we're going to liberate it. We're going to make the good, accurate stuff available to everybody. So your cell phone now or your computer is completely accurate. It makes full use of that. I'm not sure it's accurate to the same degree that the military is, but it's pretty close, and you can get very precise locations. I mentioned the OpenStreetMap business. Okay, in, let's see, 2012, Google started charging for its maps. Now, we can still use Google Maps, you and I can, but if we want to do something commercially, then you have to pay for it. You have to pay I don't know what the fee is, but some sort of royalty or usage fee. And by that time, they had already begun collecting data of what they refer to as OpenStreetMap project. And this is basically input from thousands of people all over the world, where if you live in a remote part of the world and you know of a new road that's been built or some change, then you can simply call in. Now there's some restrictions or requirements that you have to prove that you know what you're doing. You're not just gaming the system or something, but it's based on information that's collected by crowdsourcing, as I mentioned, and it's vector geographic input that has created now the International OpenStreetMap. And so the whole world is covered now with freely open source street map, that's base map information, and it includes streets and roads and other information about different locations. It includes hydrography, water, lakes, rivers, all kinds of things. And so all of this is available. So when you use MapQuest or Weather Underground or Yahoo Maps or Apple Maps, most websites now, the map you're looking at is the base map, the source in the background, the map in the background, comes from this OpenStreetMap. So it's freely available for use in any capacity, any way you want to use it. So it's really a gift by a lot of people to the world to do this. Now it's also been it's being contributed to by a group. It's called the Missing Maps Project. There's still some areas in the world where areas are poorly mapped. You don't have a lot of details. I'm going to show you a little video of
Missing
that.
Maps is a project started by the American Red Cross, British Red Cross, Médecins Sans Frontières, also known as Doctors Without Borders, and the Humanitarian OpenStreetMap team, an NGO that helps organize mapping efforts on OpenStreetMap for humanitarian groups. Since then, other NGOs, humanitarian groups, companies, and other supporters have joined as well. The goal of Missing Maps is to map out vulnerable areas before a disaster occurs to reduce risk and help speed recovery. Having better maps before a crisis will help emergency responders, aid groups, and the communities themselves. Some of the most vulnerable places in the world are lower-income urban and rural areas, and often they aren't well mapped. Missing Maps aims to literally put those areas and those people on the map by working with volunteers from around the world, as well as community members who know the area well. The project has 3 steps in each place it works. The first is where volunteers, or armchair mappers, help trace satellite imagery on OpenStreetMap, adding things like roads, buildings, rivers, and so on. Then in step 2, the Missing Maps organizations work with local groups and local people who live in these communities to ground truth and add details to the map. Details like the types of buildings, schools, clinics, hospitals, and so on, the local names for things, and a lot more. The projects often include training on different mapping and data tools, computer skills, and more. Then in step 3, humanitarian organizations and other groups use the map data that's been created to plan risk reduction projects to improve people's lives in those communities. These maps and data can be used for many things as well, such as planning projects, identifying risks, and advocating for solutions. Missing Maps aims to map 20 million people in vulnerable communities around the world, and has had a lot of success so far in places like Bangladesh, South Africa, Zimbabwe, and Rwanda. And the armchair mappers who help with step 1 can be anyone, students, companies who want to give back, or just everyday people like you. For more information, check out their website at missingmaps.org.
Okay, and what they're doing, they're contributing to the Open Maps project. And I thought I would just show you how detailed this is. So I just picked an area at random, somewhere around the globe, and I'm going to zoom into it. So I'm going to zoom into this area right here in southern Ghana to show you how much detail is available. So this is all part of OpenStreetMaps. It's all, again, freely available for use to the public. So we're going to zoom in right in there. Okay. And so here's the capital city. Zoom in there. You can see all the detail, all the roads, all of this stuff put together in this project. So that gives you some idea of the level of detail around the globe, how much information we have that's freely available. That if you want to create a mapping application or do something, you don't have to pay royalty, you don't have to pay for rights or anything. This is just, out there freely available with no restrictions. So it's pretty impressive. It's a real resource. I'm sorry, Judy?
That's in English. Are they all in English?
No, they'll, I forget how many languages, but it's available and, they'll translate the words, the lettering, all the text. Okay, talking about issues. I mentioned earlier on, well, I think I talked when we were looking at historical maps. Maps used to be top secret stuff, So when Vasco da Gama goes sailing down Africa, well, he brings the map back to the King of Portugal, and they lock it away. And there have been a couple of cases of map theft and spying where folks were executed for having stolen the map that belonged to a king or somebody. But not so much anymore. Remember I showed you this at the beginning of the course, or last term, I guess, where there was plagiarism, copying from one map to another. This was supposed to be New Amsterdam or New York, but it was really a copy of a map of Lisbon, Portugal. It was done. Well, up until fairly recently, by recent I mean a few decades ago, there was concern about map plagiarism among commercial map producers. Especially, you remember when the various oil companies were producing highway maps for us to use, and you could go in the gas station and pick up a map. Don't do that so much anymore because the various states now produce their own maps. But to show you, there were some interesting examples where the map company, I think this was ESSO, they would put things on the map that weren't really there. And it was just a way of registering or making sure that their map was not plagiarized or copied by another company. So here's a map of Michigan, the official highway map of Michigan, state highway map. And right there is a place called, let's see, Go Blue, right? And then there's one over here. I can't read it from where I am. One of them's beat OSU and the other is Go Blue. Well, they weren't really good locations. Now, what you're looking at, of course, is a rivalry between Ohio State and Michigan. You know, so they added, the Michigan map added a couple of places down here in Ohio, right at the margin, that really did not exist. And so if this was ESO, if Shell copied that map and they included those two locations, and they know that it was plagiarized. And here's another one. Oh no, here it is, Go Blue, yeah. There's another one in New York. They created a place called Aglow that did not exist. That's up north of Albany, I think, somewhere. And eventually somebody actually built a store there and incorporated. So now if you go there, it's a legitimate place on the map. But I don't know to what extent. You know, they didn't really publicize this stuff too much, obviously. They wanted to keep it secret. But you know, rumor was that it went on more than, you know, we even knew about. Okay, so OpenStreetMap, I mentioned that. It's free open source base map. Use however you see fit. Imagery is a different story. So this map is available everywhere. Remote sensing imagery. Now there is the Landsat imagery and some other ones, but if you're looking at high detail, and so this is Auburn City Lake down south of town here. I thought I would just show you, if you look carefully at Google Earth and Google Maps in some areas, they will have some information just very faintly that really shows their copyright ownership of that map. So they paid for it, and I just highlighted that area, and you can see there 2020 Google. So if you take that and use it commercially, then first of all, if you try to obscure all of those little Google things, you would be violating the law and could be subject to being sued. Or if you use it with the information, then you could also be sued, because that is assuming you didn't buy permission to use it. So imagery is a different story. There is some free imagery, but if you want to use it commercially, then you're going to have to pay a price. Let me just mention one other thing. One project that's been interesting is the Gridded Population Project. And the idea here is to create information, like you could say a map, but digital information of the whole planet, where they have reliable estimates of how many people live within a 1 square kilometer area. So divide the whole world up into 1 square kilometer. I'm assuming we're not talking about the oceans. I can't see any reason they would do that, but all the land areas. And to create that database, that information. So they've been working on that for a few years, and not only just straight population, but also population with various components, you know, male, female, income levels, things like that. It's called the Gridded Population Project. And you can see it's supported by NASA and I think it's Columbia University. Yeah, Columbia University. Okay, and so the objective is to use data from many, many different sources to come up with this estimate. Of course, you're not going to have census data. You use census data when it's available, but you don't have that throughout the world. And make sure the water area is accounted for, deal with the grid square. There's a lot of technical things that need to be done here to make all of this happen. But it is available, and you can download it. So here it is. This is total population 2015, and I've downloaded it here as a high-resolution GIF, GeoTIFF. A GeoTIFF is a standard graphic file format. GeoTIFF means that it has location information built into the file. And I've opened it here in QGIS, QGIS, which is a open source public domain geographic information system. And so I'm simply going to show you, I'm going to zoom in the area right here in Alabama. And so the dark areas indicate, here you can see the scale, the darker the area, the more people within that that region. And what we're looking at here, that's Atlanta, all of this area up here. This is Birmingham. This down here is Montgomery. And this area right here is Auburn, Opelika, right there. Columbus off to the right, okay? So this is again the gridded population data. So I'm going to zoom in further now to the Auburn, Opelika area. So each one of these pixels now is 1 square kilometer. And you can move the mouse around and point to different areas and register the attribute values within QGIS. Will show you how many people are, of course they don't have an absolute number, but how many are estimated to live within that little block that it's pointing to. And you can see it's a total of 164 people, according to this value, are estimated to live there. So it's a real interesting undertaking. It's an effort to sort of automate collection of data using a wide variety of sources. Well, what can you use? Well, satellite imagery, they do radar surveys of the Earth. Also, they collect information, how much light is radiated at night, things of that sort. And so the idea is to come up with ways of updating population data, maybe even on a daily basis based on all of these various inputs that are coming in. So you'd take, let's say, satellite imagery of various sorts. Now this is broken down, categorized by certain wave bands. And all of that then will serve as input into this gridded population database. So that's what they're working with. They're not quite there yet, so you know, it's not automated, so they're having to collect this in different ways. But eventually, it eliminates the need then to do, depending on how good they get at this, the need to do door-to-door surveys and collect data the old-fashioned way. So it's an interesting approach. So all of this has to do with data collection, data that's available, spatial data that you can use to do things in mapping, to illustrate stuff and all. Okay, it's a good place to stop. So I'll do that. I'll stop here, see if you have any questions. And then Mike and Sue are going to come in next week and talk about some GPS and remote sensing and so on. Gabi?
Why is it like, for when I was traveling for work and did Minneapolis,
Yeah,
that it got it so messed up sometimes?
it does.
That could be like, we were traveling in North Alabama near Little River Canyon, and it had us going through all these little hollers. And finally, we stopped at a, what is it, like a Quick Mart, gas station.
Right.
And said, okay, where's the entrance to Little River Canyon? You just laughed at us because we were like a quarter of a mile away. We had no idea where we were.
Yeah.
So what?
Well, that's happened to me too. There are a lot of things that enter into it. Remember that it's, and you know, I may talk a little bit about GPS technology, and I think Mike's going to do that next week anyway. It's quite a complex system of interaction between various satellites in your phone or whatever device you're using to figure out the route. First of all, you have to be visible from the satellites, and so if you're traveling through canyons and so on, that can be a problem. Another part of the technology is a lot of they use supplemental information from cell towers. So if you're communicating with the cell tower knows where you are and passes you off from one tower to the next, and so you have all of that. But that's not fail-proof either. And then there's something else I was going to say. But it's you know, the things like the weather can disturb some of that location. The routing algorithms that you use, sometimes you know, we've all had the experience of you going one way and you know to get over there, all I have to do is go up here and turn, and your device is telling you, well, no, turn back and go all the way around the world to get over there, because it's not computer or whatever algorithm it's using to compute the direction either missing a road or it's, it's just got some problem with it. Anyway, I don't know the exact answer, but those kinds of things. Yeah.
Sometimes theory is just wrong. Like you say,
Yeah.
okay, you go this way, it's like, no,
Yeah.
that's going this way. No, basically the problem.
Well, I would say this, I'm an Android user, so Siri is more wrong than Google or... Somebody else had a question? Let's see, yeah.
If you send a correction to OpenStreet, that project,
Uh-huh.
how long does it take for that to show up, say, in Apple Maps, the correction?
Yeah. Well, it may be that Apple Maps has a method for you to do that directly without going to OpenStreet. I know Google does. If you see a problem in Google, then you can communicate directly with Google. Now, there has to be an evaluation. Are you somebody who knows what they're talking about or not? But honestly, I don't know. I would assume that it's fairly quick. These things are updated. You look at the data, and everything I'm looking at these days is 2020. So it's been within the last several weeks, always up to date. So, do you have something in mind?
No.
Yeah.
Other than, well, there's several of those systems that put me on the wrong street for a little piece of a street that's wrong.
Right.
I'm just curious,
Yeah.
generally, how long it takes for the correction to get into the system?
Let me just say it's happening more and more rapidly in my experience. Remember when we were purchasing GPS systems as standalone units, they weren't part of your phone, and if it was built into your car, then you would have to pay for an update and periodically do that sort of thing, and so it would take sometimes months for something to get, assuming you did that. But now all of this stuff is happening so much more rapidly, but again, I don't know the exact time frame that we're talking about. Yeah, Harold.
Early today, you were manipulating some data, maybe sometimes almost facetiously, but it brings to mind a dilemma that I have, and that's what to believe when I read something. And it's one thing just to read a written piece.
Yeah.
You know that that's potentially heavily biased
Mm-hmm.
toward the author. But then when people start embedding data and graphs and maps, there's a tendency for it to be more believable. But then you realize how people can manipulate those things too.
Absolutely.
So I'm just saying that's a big dilemma for me today. What to believe?
Oh, absolutely. And, it's like everything else. You have to do a little bit of homework and know your sources on some of this stuff. Marilyn and I were talking about that earlier, that, mapping used to be just pretty pictures and colors and didn't really have that much. I guess it did have consequences, certainly if you're navigating. But now we're doing so much with map and we depend on these things so heavily. You really have to make sure that it's reliable, and a lot of the the standard sources. I mentioned Google a lot. They do. I'm sure they do a very comprehensive job of making sure of the accuracy. Now I'll talk about Google next time, and talk a little bit about there are a lot of issues with Google and Facebook and privacy and things like that, and so I'll get into that a little bit, but. I think it's just kind of back to the consumer to be aware, and that goes with anything. We can all be manipulated one way or another if we're not careful. Okay, gang, that's it for today. See you. Thank you.